In this video, we're going over count primes. So count the number of prime numbers less than a non-negative number n. So our first example, we're given this input value 10, and that there are 4 prime numbers 2, 3, 5, 7 that are less than 10. So we return 4. Let's go over the dot process. So we will be implementing sieve of Eratosthenes. Now how can we implement this? We are going to create a Boolean array is prime, which has a size of n, which represents the numbers from 0 to n minus 1. Now the indices represents the number, and the values represent if the number is prime or not. Now initially, all of the indices or all of the values inside the is prime array will be equal to true, with the exception of 0 and 1, because 0 and 1 are not prime numbers. Then for each of the prime number or prime index I, we are going to go through all of the multiples of I. Then we can set the cells at the multiples to false, which means not primes. So what does this mean? So for example, we currently have a number 2 or the index 2, and 2 is a prime number. We want to mark all of the multiples of 2 to false. So for example, we have 4, 6, and 8, and we continue forward on. And then we're going to mark all of those indices to false. After we have processed or created the array, we can count the number of cells. With a value of true, which means the prime numbers. Now let's go over the pseudocode. So let's first validate the input parameter. Now if n is equal to 0 or 1, we can just return 0 because there are no prime numbers that are less than n. So we're going to create a Boolean array is prime with size n. Then we're going to initially fill the array with true. This means initially all of the values inside is prime. All of the numbers is prime. Then we're going to set is prime 0 to false. Then we're going to set is prime 1 to false, because 0 and 1 are not prime numbers. Now we're going to iterate through the indices of n from 2 to n divided by 2, denoted as I. Now why we're ending at n divided by 2? Because for each of the index I, we're starting from the multiples. We're going to go do the multiples of I, and the multiple starts with 2 because we're multiplying by 2, and then multiplying by 3, and then multiplying by 4. If is prime I is false, this means the current number is not prime, then we cannot go do the multiples of I. We can just continue to next index. Now when iterate through the multiples denoted as j, where I times j is less than n, because we only want to process the multiples of I where the number is less than n. So I'm going to set is prime I times j to false, because it's not a prime number. Now after we have created the table, we are going to count the number of cells with a value of true, which are the prime numbers. So I'm going to create a variable prime. Then we'll iterate through the is prime array, denoted as, or we're going to iterate through the elements of is prime array, denoted as p. If p is true, we're going to increment prime. Then we can return prime. We can call it primes. Now let's go over the time and space complexity. For the time complexity, we get O of n plus O of n, where n is the input value. So we first created the Boolean array or the table. And then we also count the number of primes. In our space complexity, we get O of n. This is because of our is primary. Now let's go over the code. So we'll first validate the input parameter. If n is equal to 0 or n is equal to 1, there are no prime numbers less than n, so we're going to return 0. We're going to first create our isPrime array, which is a Boolean array. isPrime is going to create table. We're going to create a method which creates the table. We're going to create a Boolean array, isPrime. Then we're going to fill all of the cells with true in the beginning. And then we're going to set isPrime 0 to false and isPrime 1 to false because they are not prime numbers. And then we're going to iterate through the indices starting from 2 to n divided by 2. If the current cell or the current number is not a prime number, then we are not allowed to go do the multiples of the current number. We can just continue to the next index. But if the current number is a prime number, we want to go do the multiples of I and set all of the cells to false. Now we're going to set the multiple to false. Then we can return the isPrime array. Now we want to count the number of primes. We're going to iterate through the isPrime array. If the current number is prime, we can increment the number of primes. Then we can return primes. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.